Welcome. Let's take a look at some basic differences and things to deal with for relations and functions. The most common thing or the most important basic thing to understand is that for a function to be a function, there needs to be one and only one output. So each x value can have only one result, which is called the y value. That's why I said yes for this and no for this, where you see that there's two possible y's. Most of the time that comes out in something like this. If we have a parabola, then every point along here has an x and a y, but each x term, like for this one here where there's an x and a y, well, the x has one y that goes with it. This x value only has one y that goes with it. However, if we had a parabola that was going this way, we would now have this x here has an x and a y that's here, and the same x, but it's a different y down here. So that there's a y here, which is a negative something, and there's a y over here, which is a positive something. But in this case, it's just a matter that they're different y's. So this one is not a function. Not a function. This one, yes, it's a function. And those are actually some of the examples I'm going to go over here. But this, even though it's a little bit messy, hopefully helps you to understand the basic graphical concept. So let's start off, and what we're going to do with this chart is I'm going to be putting the domain and range here to also work on understanding the domain and range and in a couple of formats. So let's start first, the first one, with a basic linear equation like so. Straight line. So if we have a straight line for that, okay, we're going to talk about what the domain is. The domain for this is every x that also has a corresponding point on there. And it looks to me, since this is going out forever, that every x going this way and every x going this way actually counts. So we can say that in a couple of ways. The domain are all the x's that are from negative infinity, less than x, which is less than positive infinity. We can also put that in interval notation by saying negative infinity to positive infinity. And since that's every number that exists, we can also say that it's all real numbers. All real numbers. And we use that symbol for all real numbers. So of all those ways, this is the best way to be showing it at your level now. Interval notation is common for a range of numbers. Okay, I'm going to draw this line, then we're going to look at the range. So the domain with the x's and the range are the y's. Well, on the y's, every y here has an x there, and it looks to me like every y, since this goes up forever, this goes down forever, every y going up, every y going down are all being used. So the range has the exact same result. It's from negative infinity is less than y, which is less than positive infinity. A little better way to see it, which means even though it's going up and down now, we still use the same kind of interval notation. And we can also say all real numbers and use that symbol. But most of the time you will be told or expected that you should do it in interval notation. If you don't know, you should probably write it that way. Now, let's take a look at one of these where, the second one, where it is a parabola. I'm going to do a parabola where it's at 0, 2. So 0, 2 is that vertex of that point. So the domain, well, the domain are all the x's that can be used. And since this goes up forever, you have to be careful not to draw it the wrong way. In fact, if I drew it up where it looked like it was going straight, that would be bad news because it would look wrong. I mean, and you are expected to make it attempt to look more like it's supposed to. So I have it where it's going up and curving in, but never curving all the way in. And that means even if I go all the way out here to like positive 852 billion, sooner or later, this curve is going to get to it. It's going to be very, very much later, but sooner or later, going to get to it. That means the domain is all real numbers. So it's all real numbers, and I can put that into brackets as well, or I'll use brackets. And I'll use the interval notation. And then it's the range. Now the range is a little bit different. The range is only from 0 and 2 and on up. So we're including the number 2 and the numbers above it. So that means what we've got is that it's all the y's that are greater than or equal to 2 because 2 is included because it's actually on it. And in interval notation, that means we're going, oh, now I have to change that. In interval notation, that's going to be the bracket. That bracket, the square bracket, to positive infinity. Remember, infinity is always with a parentheses, but a number, the bracket like this means the 2 is included. And if I use parentheses, the 2 would not be included. But we'll see it separate the ways of doing the answers. So there. Okay, now, so that's the range in that one. For the third one we're going to do, we're going to look at one of those parabolas that's going the other way. And I think I'll take and do, I guess that'll be the center. And this will be at 8 and 0. Now this one's not a function, but the domain and range still doesn't mean we can't figure that out. So the domain here, we're going from 8 out. That means that x is greater than or equal to 8. And we can say that it's from 8 going to positive infinity. For the range, however, as we go up and down the y-axis, every one of these points, since it's going to go forever and ever, the range is going to include all real numbers. Although, again, I want to write that as negative infinity to positive infinity, or the other way with the other brackets. So let's look at a fourth one where it's what's called discontinuous. And discontinuous means that it just doesn't continue. So I'm going to do, let's say this is about where 5 is, 5, 10, 15, say 20. I'm going to do a curve like that. And what's going to help you here is I'm going to tell you what these starting points are. This one is the x is 2 and the y is 6. And this one, the x is 10 and the y is 2. All right, so different results here. It's going to be interesting. Right. So we want to know the domain and range. All right, so for the domain are all the numbers that are used. So right now, that's coming from negative infinity, because this is going to go forever, negative infinity up to the number 2, and it's going to include 2. And here, it's not going to include 10, but it's going to include all the numbers greater than 10. The domain does not include all these in-between ones. So what I'll be doing for the domain is I'll be saying it's from negative infinity to the number 2, and including the 2. And I'm going to put a U here because it's in union with, meaning that it also is going to include all the numbers that are from the number 10, but not including 10, going up to positive infinity. If I were to write this in the other way that most people are more comfortable with at first until you use the interval notation enough, I would be saying that we're going from negative infinity is greater than, it's less than or equal to 2. And then I put this semicolon, and then I would say, I have to put x in there. So I need to put the x's between those. Is less than x, which is less than or equal to 2. And then I put the semicolon, and then they'd say 10 is less than x, which is less than infinity. But I would not use the line underneath the 10 there because the 10 is not included. This, however, is the better way to show that domain. And for that, I wanted to, it wanted to kill me. Okay. Now for the range, we're going to have the same concept, because for the range, let's use green for that. It looks like that 2 is not used. So since we're not using the 2, put a circle there and put all the numbers less than, no, they're not being used. So it can't go that way. All the numbers above it are. So all the numbers here, 3, 4, 5, 6, or 2.7 and 3.2 and all that are being used. Plus, once I get up here to 6, then of course all those numbers are being used too. So here the range is simpler because even though this one starts at 6, because this one starts at 2, it actually also is going to include all the in-between ones. So for the range, I'll put that back in the blue. So for the range here, I'm simply going to say that it's all the y values that are greater than 2. Or to write it in interval notation, it's from 2 to positive infinity, but not including 2. So in this case, there's no union needed for it. What there is simply showing that it starts at 2 and goes up and doesn't include 2. That's an interesting type of real concept. But I thought then that makes this a valuable example to say, that's an interesting way to do that. I didn't mean to. I wanted to put a star here simply to show that that's important. All right, now on the next page here, discrete and continuous relation. A discrete relation is simply where it's just dots. They're not connected. Even though they look like you should connect the dot, well, we're not playing that anymore at this stage. But they're just dots, okay? And can be a function because this x value only has one y value that goes with it, x, y. And this x value only has one y, and this x value only one y, and so on and so on. Okay. Now these are relations, which means we could have like 2 of them where the x has 2 y's, but the point is it's not continuous. In discrete, that means they're not connecting to each other directly. In a continuous one, they connect sort of like that. Okay. All the points that are part of the relation all connect. The vertical line test, as a reminder, is that when you have a function, or you have what you think is a function, if you can draw a vertical line, you can cut it in 2 places, then it's not a function. Okay. So if I had another one that looked like this, okay, it gets confusing here because here I can draw lots of lines, but when I get over to here, now I see it hits like 3 different places, and so this is not a function. F-U-N-C function, I-O-N. Okay. So those are concepts to see, and the vertical line test helps you make a very quick graphical decision about whether or not something's a function. Now we're going to evaluate the function. And evaluate means to figure out what the amount is, or the result, when using a certain beginning amount. In this case, I'm going to have the input of -5, and normally you see this as f of x. That means when I do tell you what x is, it means you put it into these places. So when I say find f of -5, it means I'm going to do 3, -5, squared minus 2, negative 5 plus 7. So make sure you put it in each of the places. And then be careful of your negatives, because that's not negative 25, it's a positive 25. All right, which means you get a 75 here. And here, these two negatives make a positive 10. Okay, so you get an answer of 92. So the function, when x is negative 5, has a result of 92. Now that actually is, if this was graphing it, that would be meaning that just like it has an xy, it would mean that this was negative 5 and 92, and you could actually put that on the graph as a point, and then do, say, negative 4 and 0 and 2 and 3 like that, and you get the graph. But this is what we put as the answer. Notice that I did not do any calculations with this side. You're not supposed to. It's just simply put the things in on the other side. So let's do that now with this next one. Okay, so f minus 5m, and we're going to put it into each of these places for this. That's going to be 3 negative 5m squared minus 2m. Oh, I forgot to put minus 5. Minus 5 and m plus 7. The fact that there's an m there, so what? You've done that before when you did just negative 5m squared. Well, or if you just did m squared, you just have m squared. When you do negative 5m squared, that means it's 25 and m squared. So the result of this part is 25m squared. Okay, I'll keep it in parentheses temporarily and multiply it. Here, I'm still going to get positives, and I'm going to get 10m plus 7. I'm going to have 75m squared plus 10m plus 7. And I can't combine these like I could on the last one, because now one doesn't have an m in it. And here, these can't be combined because they have different exponents for it. So that means that the answer is simply 75m squared plus 10m plus 7. Okay, good. Bring that one up. And now let's take a look here. Oh, one that has a few more things, or a little more to it. Now, it's really no different from the m, except that we're going to have another exponent to deal with. So let's do that. We're going to use the same thing here. So I'm going to say f negative 3z to the 11th power is equal to 3 times negative 3z to the 11th squared minus 2 negative 3z to the 11th plus 7. So I'm first going to do this squaring. So I'm going to have 3 times 9z to the 22nd, because with exponents, an exponent of an exponent means you multiply it. I'm still just simply going to get plus 6 here, because the number multiplying out here doesn't affect the z to the 11th at all. And then I'm going to do 3 times 9 to get the 27 z to the 22nd plus 6z to the 11th plus 7. So f of negative 3z to the 11th is equal to that. And again, notice that from the left side, I did not use this to help with any calculations, because it's just notation. It's telling you what to do. You don't actually use the f and that number except for plugging it in for the z's. So I hope that helps with evaluating a function, because whenever you see that term evaluate, it usually means plug a number in. And thank you for listening and watching.